Good morning to all. This is Prakash. Today we are going to discuss about interhalogen compounds. What do you mean halogens? As you are all aware about the halogens are seventh year group elements. They are fluorine, chlorine, bromine, iodine, etc. They are placed in seventh year group in the long form periodic table and they are having high electronegativity. They are the right, they are placed right place in the long form periodic table. So interhalogens, where halogens among reacting each other and giving compound, they are known as interhalogens. Interhalogens. Halogens combine with halogens, they are known as interhalogens. The reason why they are reacting each other. If you look at the electronegativity difference among the halogens, there is a large electronegativity difference. At the same time, if you come in the group from fluorine, chlorine, bromine, iodine, the size is also varying due to large difference in the electronegativity and size. They are reacting each other among the all interhalogen compounds. If you look at that fluorine, which forms more number of interhalogen compounds, the reason is that it has the greatest electronegativity and smaller in size. Now nomenclature, how to name interhalogens. So example, you can take interhalogen CLF, ICL3, ICL, etc. How to name CLF? So here you can see that when you are writing the formula, the positive ion to be written first, then negative ion will be written. CLF. CLF in that chlorine is having less electronegativity than fluorine. So CLF is to be written. How to read our nomenclature? Chlorine monofluoride. Chlorine monofluoride. In the same way, iodine. Iodine ICL3, iodine trichloride, iodine trichloride. In the same way, IF5, iodine pentachloride, iodine pentachloride. So on, you can give number of examples. CLF3, chlorine trifluoride, chlorine trifluoride. These are the few examples nomenclature of interhalogens. Types of interhalogens. There are four types of interhalogens generally we can see. We can express them with general formula AX, AX3, AX5, AX7. So AX, AX3, AX5, AX7. AX type interhalogens. If you look at that, there is a mono atoms of two fluorine halogens. Example, you can take CLF, BRF, ICL, BRCL. CLF chlorine fluoride, BRF bromine fluoride, ICL iodine fluoride, BRCL bromine fluoride. In the same manner, if you look at that AX3 type interhalogens, CLF3 chlorine fluoride, BRF3 bromine trifluoride, ICL3 iodine trichloride. Now AX type interhalogens can only bromine iodine can form with that too with fluorine. Okay, and you can see that the AX type interhalogens BRF5 bromine pentafluoride and iodine pentafluoride. These are the two interhalogens. They are AX type interhalogens BRF5 IF5. Now hepta AX7. AX7 is nothing but hepta is nothing but 7. Iodine only can form AX7 type interhalogen, that is IF7. Iodine heptafluoride. Hepta is nothing but 7. Iodine heptafluoride. So this is regarding the in various types of interhalogens: AX type, AX3, AX5 and AX7. If you look at interhalogen compounds, iodine forms more number of interhalogen compounds compared with the remaining bromine, chlorine and fluorine. Iodine can form IF7, IF5, ICL3, ICL and IBr, etc. What might be the reason? As you know, iodine is larger in size and in its valency shell there is an electron lone pair of electron pairs. It can act as a basic in nature. That is the reason iodine can form more number of interhalogen compounds. And if you look at that fluorine, which is reacting almost with fluorine, bromine, iodine, the reason is that it has the small size, more electronegativity. Due to this reason, you can find fluorine can combine with all fluorine, bromine, iodine, and you are finding more number of anion fluorine in these cases. Now come to oxidation numbers. If you look at the oxidation numbers, in AX type, if you look at CLF, BRF, ICL, BRCl, IBr, in all the cases that in CLF chlorine is +1 state and fluorine is -1 state, and ICL also iodine +1, chlorine -1, so on. In AX type 3, AX type AX3 type interhalogens, where you can see the oxidation number, that cation shows +3, anion shows -3 oxidation number. And here in case of AX type, AX5 type, oxidation number is +5, and AX7 oxidation number is +7 state. So if you look at the maximum oxidation state with respect to chlorine is 3, and with respect to bromine is 5, with respect to iodine is 7. So compounds of chlorine, you can take example CLF, where it shows the +1 oxidation state, and CLF3 +3 oxidation state. And if you look at here, you are finding the oxidation numbers are 1, 3, 5, 7, all are hot numbers. This regarding the oxidation states. And if you look at that, only iodine can form heptahalide, other cannot form. And if you look at that, chlorine and chlorine also cannot form pentahalides. The reason is that if you look at the bromine and chlorine, there is a less electronegativity difference, and they are say almost their sizes also larger, so they cannot hold together. That is the reason bromine pentachloride cannot form. In the same way, iodine heptachloride or iodine heptachloride also, iodine heptabromide also cannot form. The reason is that due to larger in size, less electronegativity difference. Next, preparation of interhalogens AB type, where you can treat it is the direct combination. You can take the chlorine and fluorine in equal volumes, and at 200 degrees centigrade, if you fast chlorine combined with the fluorine, you are going to get chlorine fluoride, chlorine monofluoride. 1 mole of Cl2 is combining with 1 mole of chlorine, giving the 2 moles of chlorine monofluoride. In the same manner, if you treat with 1 mole of iodine and chlorine, you will get iodine monochloride. Okay, this is a monochloride. Now trichlorides, when ClF3, chlorine trifluoride is treated with the chlorine, then you are going to get ClF4. ClF4. So here you can see that ClF you are going to get chlorine trifluoride is treated with the chlorine, then you are getting. Now come to the thermal stability. Interhalogens are stable at nature and they are highly stable, and here due to presence of polar bond, because there is a difference in the electronegativity. So when you are subjected to ionization, these compounds are undergoing ionization, giving the ions, cations and anions. For example, you can take the ICL, you can take ICL, here ICL you can take, you can see that ICL, it is giving I plus and Cl2 minus, ICL1 Cl2 minus is giving. So in the same manner, they all are undergoing ionization and producing that ions. So IBr is giving that I plus and Br minus, so on. Now come to the hydrolysis. When interhalogens are subjected to hydrolysis, they are giving the products. They are halogen acids and halogen oxy acids. Example, you can take that BrCl, bromine monochloride. When dissolved in water, you are going to get that hydrogen chloride plus hydrogen oxybromide. Hydrogen oxybromide. I'm repeating, when BrCl is dissolved in water, you are getting hydrogen chloride plus hydrogen oxybromide. When IF7 dissolved in water, you are going to get hydrogen fluoride, iodine oxypentafluoride, iodine oxypentafluoride. Here, when interhalogens are subjected to hydrolysis, you are getting the products hydroacids and oxy acids. Hypoacids you are going to get. Now, oxidizing agent. As you know, oxidizing agent means itself undergoing reduction in ICl. When ICl is treated with the sodium, the products will be sodium chloride and sodium iodide. In ICl, iodine is in +1 state, chlorine is -1 state. When treated with the sodium, the products are sodium chloride and sodium iodide. And here iodine is reduced from +1 to -1 state. So here they are acting as a oxidizing agent themselves undergoing reduction. Preparation of AX type 3. AX type 3 interhalogens. When chlorine is treated with the fluorine, you are going to get chlorine trifluoride at 200 to 300 degrees centigrade. In another method, chlorine monofluoride is treated with the fluorine. Then the products will be ClF3 at 200 to 300 degree centigrade. When bromine is treated with the fluorine, 1 mole of bromine with 3 moles of fluorine, you are going to get that bromine trifluoride. ClF3 plus Br2 gives rise BrF3 plus BrCl. When iodine is treated with the chlorine, you are going to get that iodine trichloride. Iodine chloride ICl plus chlorine gives rise ICl3. These are some types of interhalogens. Now come to the structures of interhalogens. Here AX type and AX type 3 we are going to discuss. Generally in AX type, if you look at that ICl, you can take ClF, you can take. As you know, there is a central atom that is either in ClF fluorine and ICl iodine. Between the chlorine and chlorine, there is a bond, and on the chlorine atom, there are three lone pair of electrons, and one sigma bond is present. One sigma bond is present. If you consider the hybridization, where we can consider the hybridization is sp3 hybridization with 3 lone pairs, 1 bond pair. Oxidation state, if you consider, it is the +1 oxidation state. When we are looking at AX type molecule shape, they are to be treated as a linear in shape. Linear in shape. And here, if you look at the polarity, they are not, they are slightly polar in nature. X type examples you already come across: ClF, ICl, and BRF, etc.